Okay, let's unpack this. 8.963 billion US dollars.
Wow.
That's the projected size of the global smart clothing market by 2030. And it's growing at like over 13% each year.
That's incredibly fast.
Yeah, we're talking clothes that track your sleep, your fitness.
Mm,
Pretty amazing tech, right?
for sure.
But hang on, what's the environmental cost of all this cool stuff? That's what we're really digging into today, these hidden sustainability challenges.
And it's critical we do, because with that kind of growth, I mean, if we don't get a handle on the environmental side, the impact could be massive. Strain on resources, more pollution.
Right.
It's not about saying the tech is bad. Not at all. It's asking, okay, how do we source the materials responsibly? What happens when these things inevitably wear out or the tech gets old?
Or just how do you recycle something that's like part T-shirt, part computer?
Exactly. Can we even do that effectively right now?
Yeah. And to help us figure this out, we've got a really solid piece of research here. An academic paper, it's called The Ecodesign Transformation of Smart Clothing Towards a Systemic and Coupled Social-Ecological Technological System Perspective.
Bit of a mouthful.
It is, but it's serious stuff. They looked at, get this, 263 different studies on this topic.
That's incredibly comprehensive. That kind of meta-analysis is so valuable because it lets you see the patterns,
Yeah.
What are the recurring problems? What solutions keep popping up across all this research? So our mission, really, in this deep dive, is to pull out those key insights for you. We want to give you a clear grasp of the sustainability hurdles, but also the potential solutions being explored.
So you get a properly informed view on where this is all heading.
Exactly.
Okay, let's get down to brass tacks then. The paper talks about this linear problem. What does that actually mean for smart clothes? How's it different from, say, my regular cotton T-shirt?
Well, the standard linear model is that take, make, dispose cycle we see everywhere.
Right. Use it, talk it.
Exactly.
Yeah.
But smart clothing makes it worse, basically, because you've got two life cycles tangled together.
Yeah.
There's the textile part, the garment itself, and then there's the electronic part, the sensors, the wires, the battery maybe.
Ah, okay, so it's double the trouble.
In a way, yes. It complicates everything. Sourcing the materials is more complex. Manufacturing is more complex. And disposal, that's a huge challenge. It's not just fabric anymore.
And those stages, they come with some serious environmental baggage, don't they? Where are the big problem areas?
Oh, yeah. It starts right at the beginning with raw materials. Think about the electronics. You often need specialized materials, sometimes toxic stuff, heavy metals like lead, mercury, chromium.
Oof, not great.
Not great at all.
Yeah.
And even the textiles might need special chemical treatments to work with the tech. Then there's manufacturing. The fashion industry already accounts for maybe 10% of global carbon emissions, which is huge.
Wow, I didn't realize it was that high.
It is. And adding electronics, that usually means more energy, more complex processes, maybe more chemicals. It just adds another layer of impact.
And it's not just making them, is it? Using them has an environmental cost, too.
Precisely. Unlike your normal clothes, a lot of smart garments need power, right? They're constantly sipping energy to run sensors and data.
Continuous energy use.
Yep. And then cleaning them. You can't just chuck everything in the washing machine. You might need special care, which could have its own environmental footprint, or people just damage them easily.
Right.
But the real crunch, as the paper really hammers home, is the end of life. What happens when you're done with it?
That combination, e-waste and microplastics. That sounds particularly bad.
It's a really nasty combination.
Yeah.
When you throw out smart clothing, it becomes electronic waste, or e-waste. And we know e-waste is full of toxic materials that can leach out. And the textile part. Synthetics are already a huge source of microplastic pollution. The IUCN estimates something like 35% of ocean microplastics come from textiles washing.
35%, that's staggering.
It is. And the electronics breaking down might add even more microparticles. But the critical gap, highlighted in the paper citing Vesk and Elaine, is that we just don't have good practical ways to recycle this stuff yet.
So there's no real system for dealing with it at the end?
Largely, no.
No.
Not on a wide scale. And that lack of end-of-life solutions just keeps that unsustainable linear model going. Take, make, use, and then landfill, usually.
So the whole system seems kind of set up to fail, environmentally speaking. What are some of the day-to-day problems with this linear way of doing things?
Well, you get things like premature obsolescence. The tech becomes outdated way faster than the actual shirt wears out.
Ah, so you throw away perfectly good clothing just because the chip is old.
Exactly. Or misuse, someone washes it wrong, fries the electronics, and it's useless. The paper also flags a real lack of life cycle thinking in the design stage. Designers aren't really planning for what happens at the end.
They're focused on the cool features now, not the disposal later.
Pretty much. And then there's the ongoing energy demand during use, which adds up over the garment's lifetime. It all contributes.
Okay, that paints a clear, if slightly depressing, picture of the problem. But the paper talks about a circular opportunity. How do we actually start moving away from this linear mess?
The core idea is something called eco-design.
Eco-design.
It's a whole different way of thinking about design. Instead of just focusing on function or looks, you build environmental considerations in from the very start.
So thinking about the planet right from the concept stage.
Exactly. All the way through material choices, manufacturing, how it's used, and crucially, what happens at the end of its life. It's a fundamental shift from traditional design.
So eco-design is the approach, and the goal is this: circular economy.
Precisely. The paper really stresses that we need a paradigm shift to a circular model. The take, make, reuse, recycle idea.
Closing the loop.
That's the aim. Keep resources in use for as long as possible, extract maximum value, and then recover and regenerate materials at the end. Minimize waste, maximize efficiency.
And the paper mentions two main ways to extend the life cycle: an inner circle and an outer loop. What are those?
Yeah, think of it like this. The inner circle is all about keeping the product itself going longer. That means things like promoting reuse, maybe selling it secondhand, swapping it. Repair is huge, fixing it when it breaks instead of tossing it.
Makes sense.
And remanufacturing, taking components from old garments, refurbishing them, maybe upgrading them, and using them in new products.
Okay, so that's keeping the product alive. What about the outer loop?
The outer loop is for when the product really is finished. That's where you focus on recovering the materials. So effective recycling of both the textiles and the electronics. And where it's safe and makes sense, designing for biodegradation.
Gotcha. The paper then maps out a 7-phase circular life cycle just for smart clothing. Sounds detailed. What are the key things to think about at each step?
It really drives home that you need sustainability thinking everywhere. Phase 1, raw materials. Choose sustainable, low-impact options.
Right.
Phase 2, product design. Design for durability, repairability, easy disassembly. Phase 3, manufacturing. Clean production, less waste, less energy.
Okay.
Phase 4, packaging. Minimal, recyclable. Phase 5, retail. Think about transport storage impacts. Phase 6, product use. Encourage responsible care, longer use.
And finally,
Phase 7, end of life. Have systems ready for collection, sorting, disassembly, and getting those materials back into the loop. It needs to be planned from the start.
let's dig into some practical strategies now. The paper lists a whole range of eco-design approaches. It sounds like it's moved beyond just tweaking the product itself.
Oh, absolutely. Eco-design thinking has really evolved. It used to be heavily focused on the product. The classic 4 Rs, reduce, reuse, recycle, recover. Basically, use less stuff, make less waste.
Standard stuff.
Yeah, but then it broadened. People realized you need everyone involved, the whole supply chain, the users. You need to think about the entire lifespan. Then came more focus on designing specifically for end of life, making things easy to take apart and recycle. And tools like life cycle assessment, LCA, became important to actually measure the impact.
To quantify it.
Exactly. And now the trend is towards this much more systemic view.
Right.
Recognizing that just making a slightly better product isn't enough. We need bigger changes in the whole system.
So let's look at some concrete examples from the paper, starting with resource and material management. What kinds of strategies fit there?
Okay, so here, the basic idea is use less material overall, design smarter, more efficiently.
Right, dematerialization.
Kind of. And then be really careful about which materials you choose. Prioritize materials that are recyclable or renewable, like bio-based plastics. Source locally if possible to cut transport emissions. And crucially, use materials that are safe, non-toxic for people and the planet. Think recycled fibers instead of virgin ones, or exploring things grown from microbes.
Interesting. Okay, what about actually making the clothes? Sustainable production strategies.
A big one is on-demand manufacturing. Only make what's actually ordered. Reduces waste from overstock.
Smart.
Then adopting low-carbon tech. Things like zero-waste pattern cutting, using less water and fewer harmful chemicals in dyeing, powering factories with renewable energy. Digital tools can help here too, monitoring energy use, optimizing processes.
Using tech to clean up tech production.
Exactly. And the paper also notes that sometimes using existing local factories or traditional craft skills can actually be more sustainable than massive centralized production lines.
That's an interesting counterpoint. Now, for the designers actually drawing up these smart clothes, what eco-design principles should be top of mind?
Modular design is huge. Think clothes where you can easily swap out the electronic bit, maybe the sensor dies, or a better one comes out, you just replace that module, not the whole garment.
Ah, like modular phones, but for clothes.
Exactly. And designing for durability, obviously, using tough materials, making sure the electronics are well protected, but also this interesting idea of emotional durability.
Emotional durability. What's that?
It's about designing things people actually form a connection with, things they value beyond just function. If you love a piece of clothing, you're more likely to care for it, repair it, keep it longer.
I like that. It's not just about physical toughness. Okay, what about when it does finally wear out? How can design help then?
That's designing for end of life. Choose materials that can be recycled easily. Avoid complex mixtures that are a nightmare to separate.
Like blended fabrics.
Yeah, or inseparable electronics. Design it so it can be taken apart easily. That facilitates both recycling and remanufacturing, taking old products, fixing them up, maybe upgrading the tech and putting them back out there.
The paper also flags data, modeling, and measurement. How do those fit into eco-design?
LCA lifecycle assessment is the main tool. It lets you measure the environmental impact across the whole life cycle, from cradle to grave, basically. That data helps designers make better choices.
So you know where the hot spots are.
Precisely. You can also analyze logistics, using IoT maybe, to cut energy use in transport. And using materials with recognized eco-labels or certifications helps everyone make more informed choices.
What about governance and involving people? Stakeholder engagement.
Crucial. Part of it is designing to encourage sustainable user behavior. Maybe the product itself guides you on how to care for it properly or dispose of it. Raising awareness is key.
Right.
But it's also about collaboration, getting everyone in the chain, suppliers, brands, retailers, recyclers, even policymakers working together. The paper even mentions blockchain as a potential tool for transparency here, tracking materials and conditions.
Okay, and product service systems. That sounds like moving away from just selling stuff.
Exactly. It's a big shift. Instead of selling you a smart running shirt, maybe a company offers a personalized running coaching service enabled by the shirt.
Renting the shirt or subscribing to the service?
Could be, or offering robust repair and upgrade services as part of the package. The focus shifts from selling units to delivering ongoing value. It's about access over ownership, which can drastically cut down on new production.
And social innovation design. What's that last one?
That's by using design thinking to tackle broader social and environmental issues within communities, maybe promoting local repair networks or equitable access to sustainable options.
It's really fascinating how the thinking on eco-design has become so much broader. The paper mentions Verbeek and Norman theories about technology's influence.
Yeah, Verbeek talks about the moralization of technology, the idea that tech isn't neutral, it shapes our ethics and behaviors. So a well-designed smart garment could subtly nudge us towards more sustainable actions.
Yes.
Maybe it clearly shows its energy use, or makes separating components for recycling really intuitive. That links to Norman's theory of affordances, how an object's design suggests how it should be used. Good design makes the sustainable choice the easy or obvious choice. Baumru's work builds on this, specifically designing for sustainable behavior.
And this all feeds into that bigger picture, the systemic thinking you mentioned,
Yeah.
connecting to things like the UN Sustainable Development Goals.
Exactly. The paper argues that these challenges are interconnected. We can't just tweak individual products. We need deeper structural changes in how we produce and consume. Manzini and Vizzoli are mentioned as advocates for this systemic shift.
Right.
The UN SDGs provide that broad framework for sustainability, but progress is patchy. It highlights that we need this holistic transformation, not just isolated fixes.
Which brings us neatly to this social-ecological technological system framework. SETS. Sounds like a way to capture all that complexity. What is it exactly?
SETS is basically a lens to understand the complex dance between three key systems. Our social systems, governance, culture, economy, our ecological systems, the natural environment, resources, and our technological systems, the tools, infrastructure, knowledge.
Oh, okay. Society, nature, tech.
Right. And it emphasizes that these aren't separate silos. They constantly interact and influence each other. Decisions in one area ripple through the others.
So for smart clothing.
It means true sustainability isn't just about a better battery or recycled fabric. It's about understanding how that tech interacts with user behavior, with economic models, with resource limits, with waste systems. It forces you to look at the whole picture, the feedbacks, the potential conflicts or synergies between these domains.
And within that big SETS picture, the paper proposes a specific eco-design framework with 4 pillars, heavily leaning on digital tools like digital product passports. Let's tackle that first pillar, digital infrastructure and traceability. What exactly are these DPPs?
Okay, think of a DPP as a digital ID card or a logbook for a specific garment. It holds all sorts of data about its life story.
Its life story.
Yeah, where the materials came from, how it was made, its specs, repair history, recycling instructions. It's like a digital twin almost. And this info is linked to the physical item via something like a QR code, an RFID tag, or an NFC chip.
So you can just scan it.
Potentially, yes. And crucially, it's not static. The passport can be updated throughout the garment's life.
A living document for every piece of clothing. The paper mentions different tech options: QR, RFID, NFC, blockchain. Any key differences?
They offered different trade-offs, as Table 2 shows. QR codes are cheap and easy to scan with a phone, good for basic info. RFID is better for tracking lots of items automatically, say in a warehouse. NFC is good for secure, close-range interactions like tapping your phone.
And blockchain.
Blockchain offers that decentralized, tamper-proof ledger, great for building trust and transparency when many different companies are involved in the life cycle. You're seeing initiatives like Surpass and Circular.Fashion exploring how to combine these best. Maybe RFID tracks movement, and blockchain verifies the data added at each step.
Okay, so how do these DPPs actually help make things more circular, starting right back at the raw material stage?
Transparency is the big win here. Supply chains for clothes and electronics are notoriously murky. DPPs can digitally record where materials came from, maybe even their environmental footprint data.
So you can verify claims about sustainable sourcing.
Exactly. Copelar's research is cited, showing how DPPs could track critical raw materials. This helps companies source responsibly and allows you, the consumer, to potentially see that information and make choices based on it.
What about during design and manufacturing? How do DPPs help there?
They can store vital data for designers and manufacturers, things like energy used during production, results of impact assessments, certifications, detailed lists of components, even instructions for how to take it apart later without breaking things.
Useful for repairs and recycling down the line.
Definitely. Things like environmental product declarations, EPDs, which standardize environmental data, could be linked directly to the DPP.
And while the consumer is using the garment, sounds like DPPs could unlock some cool features.
For sure. Since the DPP can track usage, maybe how often it's worn, battery health, any repairs done it opens doors for better maintenance and optimizing performance.
Like getting an alert before a sensor fails.
Potentially, yes. And it's fundamental for those product-as-a-service models we talked about. The service provider uses DPP data to offer personalized advice, predictive maintenance, maybe software updates. Plosianic's study even showed DPP data helping sort e-waste more effectively by telling recyclers exactly what's inside.
And that leads to the final stage, recycling. How do DPPs help close that loop?
By giving recyclers the information they desperately need. What materials are in the specific garment? How do I get the electronics out safely? What parts are valuable?
So less guesswork, more efficient recovery.
Exactly. Clear disassembly instructions, material compositions. It helps recyclers sort better and recover more value. Manufacturers could also use data from returned products via DPPs to inform remanufacturing. And it could guide you, the user, on exactly how and where to dispose of it correctly.
The paper does raise a flag about the energy used by all this digital infrastructure, though. That's a fair point, isn't it?
Absolutely. We can't overlook the footprint of the servers, the networks, the data centers needed to run these DPP systems. It's crucial that this infrastructure is powered by renewable energy and designed for maximum energy efficiency itself. Otherwise, you're just shifting the environmental burden.
Right. Okay, let's move to the second pillar. Ecological technological coupling, ET coupling. What's the core idea?
ET coupling is about consciously designing the relationship between technology and nature, trying to make sure our tech minimizes harm to the environment and ideally even helps it.
So making tech work with nature, not against it.
That's the goal. Acknowledging that tech can cause degradation, resource depletion, pollution. But it also holds the key to solutions like efficiency gains or cleaner processes. It's about fostering a positive interplay.
How does that translate into practice for smart clothing? It mentions responsible sourcing and production.
Yes, this pillar is all about the materials and manufacturing, using greener materials and cleaner production methods for both the textile part and the electronic components, reducing the carbon footprint, water use, chemical pollution across the board.
So specifics for the textiles.
Prioritizing things like organic cotton, recycled fibers, ensuring fair labor conditions, that's a social aspect tied in. Using local resources where possible. Transparency in sourcing cuscs work using QR codes and embroidery to track social factors is mentioned as an example.
And for the electronics.
choosing components that are energy efficient, durable, made with less toxic materials, exploring biodegradable materials where feasible, and crucially, designing them for easy removal and recycling. Low-power sensors are key too.
The paper has a table with examples of these eco-materials. Any highlights?
Recycled polyester, or PET, is a big one on the textile side. Made from old plastic bottles or fabric scraps. Generally uses way less energy and water than making virgin polyester.
Right. Closing the loop on plastics.
And it integrates well with electronics usually. On the tech side, there's promising research into bio-based materials, things like cellulose or PLA plastic derived from plants. Guridi's work on cellulose touch sensors is an example. These could be biocompatible, maybe even biodegradable.
So replacing traditional materials with greener alternatives.
Yes, and also just generally sourcing recycled components for the electronics where possible, and designing things so you can easily upgrade or replace a part rather than the whole garment.
Okay, pillar 3, social-ecological coupling. SE coupling. This sounds like it's about people and the planet interacting.
It is. SE coupling focuses on that interplay between our social systems, how we live, our values, our economies, and the ecological systems we depend on. Our demands impact the environment, and environmental health impacts our well-being.
A two-way street.
Exactly. So for smart clothing, it means sustainability isn't just about the tech specs. It's deeply connected to how we as a society consume, use, value, and dispose of these items. Design needs to consider these social dynamics alongside the ecological limits.
And this leads to the 5 R's for smart clothing, shown in Figure 7. What are they?
They build on the basic R's. For smart clothing, the paper emphasizes remanufacturing, fixing up old ones, reuse, keeping them in circulation longer, repair, making them fixable, both fabric and tech, reduce, using less material in the first place, and recycle, recovering materials effectively at the end.
How does design enable these?
Modular design is key. Again, makes repair, upgrade, and separating materials much easier. Sherry Huang's work on 3D printed modular smart textiles is cited as an example of designing specifically for this.
Smart clothing must have unique durability challenges too, beyond just the fabric wearing out.
Definitely. You need the fabric to last, but you also need the electronics to be reliable over time. Can they handle moisture, bending, temperature changes? How long will the sensor keep working accurately?
So technological reliability is crucial.
Absolutely. Choosing robust components, protecting them well within the garment design. The paper even mentions research into self-healing textiles, materials that could automatically fix small tears or damages.
Wow. Sci-fi stuff.
Getting there. And again, emotional durability and user-centric design, like Fairphone's approach with phones, making users part of the repair and upgrade process, helps extend life too.
And upgradability is another big one here, especially with tech changing so fast.
Critical. Designing with standard connections or interfaces means you could potentially swap in a new sensor or a better battery down the line, keeping the garment relevant for longer without tossing the whole thing. Reduces waste massively.
Okay, final pillar. Social-Technological coupling, ST coupling. This is about dematerialized use and services.
Yes, ST coupling looks at how tech, particularly digital tech, can shift us away from relying solely on physical products towards getting value from services. It's about leveraging product service systems, or PSSs, and making them smart.
Dematerialization, less stuff, more service.
Exactly. Less focus on selling units, more focus on delivering performance, experiences, outcomes. So instead of buying the smart shirt, you subscribe to the fitness insights delivered by the shirt and its connected platform.
How does that help the environment and the user?
The idea, often called service-dominant logic, is that by focusing on service, companies are incentivized to make products durable, repairable, upgradable, because they often retain ownership or responsibility. It decouples revenue from sheer volume of production.
Right, they want the shirt to last if they're providing the service.
Precisely. Digital tools are key here. Cloud platforms, IoT data, AI analytics. Figure 8 shows a framework for this data-driven value creation. The intelligence comes in a couple of ways. First, during design using virtual prototypes and simulations instead of wasteful physical ones. Virtual fitting tech helps too.
Designing digitally to reduce physical waste.
Yes. And second, during use analyzing the sensor data via IoT and algorithms to understand user needs better, personalize the service, maybe predict maintenance needs. Zhang's work on using cloud analytics for predictive maintenance in textile factories is relevant here too.
This framework covers a lot of ground, but how do we actually measure if any of this is working? How do we assess the sustainability of these complex systems?
That's a huge challenge, and the paper addresses it. Standard LCA methods are good for single materials, but assessing integrated electronic textiles, the whole package is tricky. There isn't really a settled LCA methodology for smart textiles yet.
So existing tools fall short.
They have limitations. Table 4 compares different approaches: LCA for electronics waste, various environmental footprints like carbon or water, eco-efficiency analysis, industry tools like the Higg Index.
What are the main gaps?
While measuring environmental stuff in textiles is fairly mature, adequately capturing the social and economic sides, especially these complex global supply chains, is much harder with existing tools. Eco-efficiency or the Higg Index try, but they can be limited.
So we need better ways to measure the social side.
Yes. Social Life Cycle Assessment, SLCA, aims to do that more thoroughly using specialized databases like SHDB or PCELA. But gathering reliable data across the whole value chain remains incredibly difficult.
Sounds complex.
It is. The paper suggests we probably need a hybrid approach using quantitative data where we can emissions, water use, cost, and qualitative assessments for harder to measure things like chemical safety impacts or social conditions. Getting a truly holistic picture is tough but essential.
This has been incredibly insightful, a real deep dive into the complexities and possibilities. Let's try and pull together the main takeaways.
I think the clearest message is that the current linear take, make, dispose model just won't cut it for smart clothing. It's fundamentally unsustainable.
Right. Change is needed.
Absolutely. The shift has to be towards a circular economy. And eco-design principles, guided by that broader sets framework thinking, considering social, ecological, and technological factors together, are the way to get there.
And the key ingredients for that shift.
Robust digital infrastructure, especially digital product passports, for transparency and tracking. A serious commitment to responsible sourcing and greener production for both the clothes and the tech. Rethinking life cycles, designing for durability, repair, reuse, modularity, upgradability, and embracing those dematerialized service models instead of just selling more stuff.
And for you listening in, we really hope this discussion has given you a clearer, more nuanced view of what making smart clothing sustainable actually involves. It's about looking past the hype at the real challenges and innovations.
Yeah, the goal is to equip you with an informed perspective. But understand that smart and sustainable don't have to be opposing forces. They can and must be linked for the future of apparel.
So here's something to ponder as we wrap up. Technology is becoming ever more woven into our lives, literally into our clothes. How can we, all of us, as consumers, designers, companies, actively push for a future where smart is sustainable, where they're two sides of the same coin? What part will you play in helping to close that loop?